Hello! So today in this video I will start a new course in my cloud architect learning path, and it's this one: implement load balancing on compute engine. It should be a 3-hour course. Let's see how it's structured. So we have this first, so it has only one module with only 5 labs as activities. Okay, so we have a practice focused module. Let's see if we can do it in less than 3 hours. Maybe, let's say, a couple hours or one. Let's see if we can do it. So yeah, let's see, so you can see what we're talking about. Let me modify a bit this. Okay, so yeah, I was talking about these 5 labs. So it's yeah, a module, only labs module. Let's go then. Start module. It says 40 minutes. It's about creating a new instance of virtual machine from the cloud console, install nginx, create a new instance with gcloud command. Okay, let's go. Let's see if we can do this in maybe less than 15 minutes. Okay, so let's go. These are the credentials. So English. Yeah, okay. Okay, this one. Nice, let's go. So we need to create an instance with this name. Compute engine, VM instances. Create instance. We put this name here. GCE lab, region 4 is 4A, E2 medium. So the machine is already the good one. Let's see, a new project. Okay, click OS and storage. A new project has a default resource quota, which may limit the number of CPU cores. So this is okay, you can request more, blah blah blah. Debian, Linux 11, balanced persistent disk, 10 gigas, allow HTTP. So allowing HTTP will automatically create a firewall rule to allow HTTP traffic on port 80 in the default network. Create, and then SSH into it. Okay. Then we should just install the nginx. Yeah, and that's all. So the OS and the 10 gigas, it's okay. I mean, I don't care. I don't think they will check exactly that aspect. And the firewall rule was last. Yeah. Create. So okay, this is quite simple from the console. I've seen that at the end we will try performing the same actions, I think, or something analogous, but with the Cloud Shell using what's the name? Gcloud command. Okay. Hey, wow. We had an error here. Well, who cares? The important thing is that it works. Okay. So let me see if I memorized correctly what is necessary to do in cases like this. So just to see if we need only do we need only Apache? No, Apache Nginx. So let's go. First of all, we need to update our packages. Then we install Nginx. Right. Then after we installed it, we check if it's running with ps, and then pipe. How do I pipe on this? Oh, I can't see. I don't know what keyboard I'm using. Okay, found it out. Grep Nginx. Okay, so it says we have a couple processes. Let's see. So we can even check the page here. Welcome to Nginx. Great. Now we can check the progress, and then instead of using the Cloud Console, you can use the gcloud commands. Gcloud compute instances create gclab2, machine type E2 medium, zone will be equal to zone, but we do not have oh, I see. So they did some work before. So certain compute engine resources live in regions or zones. A region is a specific geographical location where you can run your resources. Each region has one or more zones. For example, the US Central 1 region denotes a region in the central United States that has zones US Central 1 A, B, C, and F. So resources that live in a zone are referred to as zonal resources. Virtual machine instances and persistent disk live in a zone. To attach a persistent disk to a virtual machine instance, both resources must be in the same zone. Similarly, if you want to assign a static IP address to an instance, the instance must be in the same region as the static IP. Wow, the IPs also are regional. Okay, so set region and zone. Now, in our okay, we go from here in our Cloud Shell. I'm doing it from Cloud Shell, but one can also install the SDK locally and launch the same commands. So it will be gcloud configuration. We configure the command gcloud by setting the compute region to US East 4. Okay. Now we also create an environment variable called region, which will memorize the region, and then we do the same for the zone. So in that region we want the zone A. Now we will be able to use this command, which has this variable as value for that tag, the tag zone. Okay, now we can launch this command. It will take the time it takes for this other interface to run the same command. As you can see, it's already running, it says. Let's see. Nice. Now expected output, blah blah blah. Yeah. So the new instance has these default values. So this is the manual, the help tag for the create command for the compute instances in gcloud. Yeah, so now we exit, then we go refresh. So you can also use SSH to connect to your instance via gcloud. So let's say from gcloud we SSH we say yes. So we created an empty passphrase, and now you can see we are using this user, we're impersonating this user on this machine. So okay, do you want to continue and blah 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 exit. We can also do the sudo apt get update, and one can also install nginx. So sudo apt get, oh Jesus, install -yes nginx. Okay, so it's already doing it. Now we can use processes. We can pipe. Yeah, whatever. Pipe grep into grep. We are looking for nginx, and we have it running. Now we can also check it here. Oh, what happens? Why it's not possible to click on it? This okay, so we did not enable HTTP on this machine. So through which of the following ways can you create an a VM instance in Compute Engine, Cloud Console NG. Yeah. Wow, what a difficult test. So we ended this lab in 13 minutes. And we can go to Compute Engine, Quick Start Windows. What the hell? So let's start this lab. So in this one, we will experiment with Windows, launching Windows instances. It should not be so different. And instead of using SSH, we will use RDP to connect to the machines. Therefore, oh yeah. So let's activate the Cloud Shell. So we can list the active account name with this command. We will continue using the active one. We can list the projects. Then we can create a virtual machine. We will create it from the console. Create instance with whatever name, US East 1D E2. So Windows Server 2022 data center. Okay, select, create. Now we have this virtual machine with Windows. Okay, remote desktop, G-Cloud compute instances, get serial port output instance, so on, blah blah blah. Okay. Oh yeah, okay, so instead of instance this one, I imagine I have to replace the instance name. Okay. What? Okay. Okay, I think we are just receiving a longer output. So gcloud compute reset Windows password instance, blah blah blah. So we go here. Instead of instance, we put our instance name. So we put our instance name here, and instead of username, we put admin. Yes. Okay. So resetting, blah blah blah. The password now is this one. I will take note of it. Okay, so if you're using a Chromebook or other machine, blah blah blah, it's like an RP already installed in the computer. Click in the icon. Spark View extension. Okay, I will use the Spark View extension. But add to Chrome, this item can only run on Chrome OS. What the fuck? RDP, remote desktop connection. So let's see if I can share this window with you. Yes. It's horrible, however. So computer. What's this one? Okay, connect. Now it's asking me the password. Yeah. So, oh shit. Yeah, so now what I have is this giant window here. Black window. Which is the window in which from which I can control the virtual machine. Okay, kind of slow, but works. It's loading. Let's remember it's still Windows. Okay. So we really completed this lab, and we can actually quit it. So now we've done it, and we can close the lab window. We need to complete this quiz. We can create a Windows instance in Google Cloud by changing its boot disk to Windows image. Which command is used to check whether the server is ready for an RDP connection? Get serial port output. Okay, Therefore, we can end this lab. Now we can continue with the next one. Start. So let's see, setup, yeah, so let me open this as usual in incognito. Okay. So we activate the Cloud Shell. Okay, so we have the list of projects and accounts. We go by configuring the environment, understanding regions and zones, blah blah blah. So we select first of all this region here, US East 1. We set that region. We check if it was set. We set the zone. And we get the zone. So now we go to config get value project, and we get these informations, the project ID basically, and then we execute a describe on that project. So about our project, we can see all these informations. We have these quotas for networks, snapshots, firewall, static address, forwarding rules. Then we have a link to this project. Okay. Setting environment variables. Now we go to project ID. We export it. We export also the zone. And then we have this final test. We echo these variables. Then we create a virtual machine with the G-Cloud tool. What? It will be called GC Lab 2. It's okay. Now we have an output which will give us the status of the machine. To open a helpful create command, blah blah blah. Run the following command. Config. View list configuration in your environment. Config list. So we have all these configurations. Accessibility, component manager, compute, core, metrics, list your components. Okay, so your current Google Cloud version is, your Cloud CLI version is this one. The latest version is this one. Update available. So gcloud core libraries available, alpha commands available, beta commands available, appctl, which looks something related to kubectl, it's not installed, as also Firestore, SQL Proxy v2, Spanner emulator, container registry docker credential, customize, log streaming, manage Flink, Spanner, Terraform tools, Anthos, config connector, enterprise certificates proxy, kubectl EDC, App Engine Go extension installed, artifact registry installed, BigQuery command installed, bundled Python. Okay. So the command was gcloud components list. Now we can go to filtering, command line output. So gcloud compute instances list. We have this. So list the GCP virtual machine, filter name. So in gcloud we have these filter tags, which will allow us to filter, for example, by name, because we know that the columns here are names on machine, preemptible internal IP, external IP. So we can list instances, or in general, I think when we launch a list command, subcommand in gcloud, we can establish this type of conditions. Name equals gclab2. Okay. So then we have the possibility to list the firewall rules, which are for the default for firewall rules for the default networks. So as we can see, each of these rules has the network. Oh, come on. They all have the condition to pertain to the default network. So we have the same for results. Then we have the possibility, for example, to list and filter the firewall rules, allowing a second condition saying that we want only ICMP protocol related rules. And we have two rules. The one that says default allow ICMP and default allow internal. Now we can connect to the VM instance from the same here with an SSH connection, empty phrase. Okay, to leave the passphrase empty. Now we install Nginx in that machine. I don't care, I already did it before. When using computer resources such as virtual machine, so we exit from here because yeah, I don't care in this moment. I already tried before doing this. So now we gcloud compute firewall rules list again. But Okay, so in reality it was supposed to stay in that virtual machine and launch the compute firewall rules list from here. What? Okay, so I'm not understanding. Yeah, it doesn't make sense to launch this command in the virtual machine as it doesn't have the gcloud installed. But it says from the above you can see that there are two networks available. Default networks where the virtual machine is located. But how do I understand this? Sorry. Try to access Nginx service running on the GC Lab virtual machine. Okay, so now I see. Okay. Update file rule to allow. Okay, so ingress priority network allow rules tags HTTP server. Okay, so for compute firewall rules, create default allow HTTP direct ingress priority 1000 network flow blah blah blah. So we're allowing in these VPC, we're creating a firewall rule which allows HTTP. Oh, I see. And to allow it, we need target tags. So this will be valid for machines having this tag. Okay. So now list the forward rules for the project. Allow HTTP, verify communication is possible for the HTTP to the virtual machine. So now we're using Carl with HTTP into the machine. So we can filter, and then with the tag format we can extract only certain values. We want the value external IP. It says it wasn't possible to connect. Let's see if we can do it from here. What's happening? Oh well, I didn't install Nginx. As simple as that. So yeah, as I did not install Nginx in the machine, of course, there will not be any HTTP, any service listening on HTTP protocol. But I don't care. I already tried that. So task 5, viewing the logs. So yeah. The system log. So gcloud login logs list. Login logs list. So what is doing this command? Viewing logs is essential to understand the working of your project. Use gcloud access to access the different logs available on Google Cloud. So view the logs that relate to compute resource. So filter for a line which contains compute. We have logs related to GC, guest app, agent manager as config, cloud audit, compute. And now we can read the logs related to resource or GC instance. We can read the last 5 entries, right? Okay. Logs of a specific virtual machine. Resource type, GC instance, and labels. Instance name, GC lab. What? It's not reading anything. We do not have any log. So 3 basic ways to interact with cloud services and resources are 3 basic ways to interact with services and resources: the Cloud Console, client libraries, and CLI. And lab, everything good. Good lab. Next lab. So start. Incognito. Let's go. Password. United Kingdom will be good. Yeah. Okay, so objectives, setup and requirements, access to standard. Yeah, okay. Activate the Cloud Shell. So let's set up the default region and zone for all resources. Okay, US Central 1, Central 1C. So now we create multiple web server instances. So create a virtual machine www1 in your default zone using the following code. So gcloud compute instances create www1, which will be in zone US Central 1C, tags network LB tag, machine type E2 small, image family Debian 11, project Debian Cloud. Metadata, so when the virtual machine starts, we'll execute this bash script, the update, installation of Apache, and restart of Apache. Okay, so create a virtual machine www2 in default zone using the following code. We use another shell to execute in parallel this second command. Create another virtual machine, so let's go and execute it here. Create a firewall rule to allow external traffic to the virtual machines. So the target which we'll use is the one network LB tag which all these machines have, I think. Yes. Okay, so let's go here and create it. So the first machine was created, the second machine was created, and the third one too. We have also the firewall rule created. Now you need to get the external IP address of your instances and verify that they are running. So let's go now. Verify that each instance is running with Carl. Okay, Carl, external IP address. I will start from the first one. Carl HTTP. Nice. Nice. And this other IP. Nice, okay. We have them all. Configure the load balancing service. Now we create in compute addresses, create network LB IP1. In the same region, add the legacy HTTP health check resource. So we have a health check to this load balancer. HTTP health checks. Now I think we will create a service and the backend. Add a target pool in the same region as your instances. Run the following create to the runs and use the health check which is required for the service to function. Target pools, create www pool region instance, and we also assign this basic check to it. So add the instances to the pool. Nice. Yes. What? Wait. G-Cloud compute target pools list. So we have www pool, US Central 1, session affinity, doesn't have a backup, has a basic check, health check. Okay, now we want to add to this guy these instances. So G-Cloud compute target pools, add instances, ww pool instances, www w1, www2, www3. Did you mean zone, for instance? See. how do I put it? Zone. Zone minus zone. Let's see. US central 1 minus C. Okay, instances on. Oh, but whatever, we did it. So if we go to gcloud compute target pools list. Target pools ww pool describe what? It's US Central 1, so it's choice 34. Okay, so now we have these 3 instances assigned to this pool. Sorry. Therefore, now we added the instances add a forwarding rule. So now we say to the target pool how to forward the rules, how to forward the requests. Now send traffic to your instances. We basically, first of all, use a describe to have an understanding of these forwarding rules. So we configured this load balancer to forward to this pool the requests. So now we have this forwarding rule registered here, and it's called ww rule. Access the external IP address. So now if we go to IP address, we memorize the IP address here, and we can describe WW region central format JSON. So we format in JSON, we extract the JSON basically from here. JQR IP address. So I think that now we will iterate this. Oh, I see, because we can extract it from here somewhere. IP address, this one. Okay, now use the curl command to access the IP address, replacing, yeah, okay. So we are sending some traffic. We can stop now. Create an application load balancer. So this load balancer, external IP address for your load balancer. Wait, so network lib. Okay, so we have a network load balancer which basically sets the rules based on address rules. Now sorry, I already did this. Okay, so let's do it again. And we have the load balancer, external. Yeah, okay. Oh no, but this is old stuff. So first create the load balancer template. Now instance template, create LB backend template. So we are creating an instance template, then which is based on, no, it's not based on a existing machine. It's creating by defining the machine again with the same definition, but not starting from the machines which exist. Then we can see let you operate apps on multiple identical VMs, create a managed instance group based on the template. So now that we have the template, we can create a managed instance group. Now we create a forwarding allow health check firewall rule. Yeah, it takes a while because the MIG will actually create some virtual machines. So this firewall rule will allow health check. So in the network, in the default network, we allow ingress requests, which source ranges. Basically, these are our virtual machine IP ranges. Not virtual machine, but these are the health check services IP addresses from which we will receive this request. We assign a tag and it will work on TCP 18. So now we can create the load balancer with IPv4. This is an address range. I'm not sure if it's an address range. So now it is around, so set up a global static external IP address that your customer use to reach your load balancer. Okay, so it's an address, literally we are creating. Click for here, not that IPv4, that copy down this IP address you need to refer to later this. Okay. Okay. Create a health check for the load balancer. Health check create HTTP. Okay, so now I see. So this is for firewall rule, and then this is create. We create a health check. Okay. HTTP port name. Instead. Okay, so we have our health check. Create a backend service. Add your instance group as the backend to the backend service. So backend service create, add backend. Create a URL map to route the incoming request to the default backend service. So compute URL maps, create web map HTTP default service web backend service. Okay. Requests. Okay, so URL map is a Google Cloud configuration resource used to route requests to backend services or backend buckets. For example, with an external application load balancer, you can use a single URL map to route requests to different destinations based on the rules configured in the URL map. Okay. So these will be okay. Create a target HTTP proxy to route the request to your URL map. Target HTTP proxies. Create HTTP proxy. Create a global forwarding rule to route incoming requests to the proxy. Create an application load balancer. Test traffic sent to your instances. Now, well, it's finished, and it consists in only going to the load balancer. In the backend section, we can confirm the health. When the VMs are healthy, replacing it with you can check basically. But yeah, I trust them. In this case, I don't care to verify. Okay, we're at the end. So here we are just going to create a project and set up an HTTP load balancer. So it has only 2 tasks, but it looks long. I understand. Yes to everything. Yeah, I agree absolutely. take all I have. So here you have this view now. So okay, we have everything set up, I think so. We also have already a project with an instance and a fiber rule. So you have started a new role as a junior cloud engineer for Julie Inc. You are expected to help manage the infrastructure at Julie. Common tasks include provisioning resource for projects. You are expected to have the skills and knowledge for these tasks, so step-by-step guides are not provided. Some Julie Inc. standards you should follow are: the default region is US West 4 and West 4 bit zone. Naming normally uses the format team resource, for example, Nucleus Web Server 1. Make sure to create an instance template in global location. Allow cost-effective resource sizes. Projects are monitored, and excessive resource use will result in containing project termination and your termination, so plan carefully. This is the guidance. The monitoring team is willing to share unless directed. Oh fuck, this is what happens. Sorry about what's happening here. Yeah, leave, and this is the new one, right? See for okay, yeah, I'm in the right place. Use E2 Micro for small Linux VMs and use E2 Medium for Windows or other applications such as Kubernetes nodes. As soon as you sit down at your desk and open your new laptop, you receive several requests from the Nucleus team. Read through each description and then create the resources. Create a project jump host instance. So we're going to name the instance. Okay. Create the instance in the US West 4B zone. Use an E2 micro machine type. Use default image Debian Linux. Create. Set up an HTTP load balancer. You will serve the site via Nginx web servers, but you want to ensure that the environment is fault tolerant. Create an HTTP load balancer with a managed instance group of 2 Nginx web servers. Use the following code to configure the web servers. The team will replace this with their own configuration later. So you need to create an instance template and use the default machine type. Make sure you specify to medium as the machine type and create a global template. Instance templates. Create an instance template. Create a managed instance group based on the template. Instance groups. Description, instance template. Create a firewall rule named accept TCP, blah, blah, blah. Create a health check. So instance, auto scaling, auto healing. Okay, auto scaling, auction, auto healing. Okay, we created the managed instance group. Create a firewall rule named as accept TCP rule 925. So low traffic 80 TCP. For the default network, imagine. Create a health check. HTTP allowed. So we need to go and modify our machines here in the template, and then maybe in the instance group. Let's see if modifying the template we obtain the change also there. Create. So it looks like we cannot change this. Therefore, I need to delete it. So let's delete the instance group. And let's go to the instance template and delete it also. So I do not have permissions for this. I will just create another template. Another template, global, E2, medium. Okay, we have everything. Networking, network tags, HTTP allowed, right? Let me see. So in the VPC network firewall, the rule we created is working with the tag HTTP allowed. Okay, so the other characteristics of our template are not defined. So we can create this again. We can create the managed instance group. Create instance group based on, my god, instance templates. So the instance group that we just created is this one, the one finishing in 005. You select it, blah blah blah, and create, yeah, location is West 4B, right? Yeah, I think so. Yeah. So West 4B, and the rest looks like we will leave it as it is. Now create a firewall named accept blah blah to allow. Okay, create a health check. So we go to health checks. We create a health check. Basic check. It will be global TCP port 80. And we just create this. Now create a backend service and add your instance group as the backend to the backend service group with named. So to create a backend service, where do we go? I know how to create it for the case of a CLI network. Backend service. Okay, so in load balancing, backends, create backend service, global backend service, right? BE service So it will be your instance was the backend to the back, so with the name port 80. Backend type instance group name port HTTP 80. Jesus Christ, but give me at least an example. I just need to understand the syntaxes. I don't care about all this shit. Name port must be lowercase letters, numbers, and hyphens. Like this, HTTP 80. GCP named port. So you see this, the syntaxis is this one. What the fuck? Okay, I will just create it. No, fucking hell. Fucking Jesus Christ. Oh my god. Oh, Jesus fucking Christ. So I just closed the lab. When you close it, you need to restart it from zero. It happens, nothing special. Now we'll go all with Cloud Shell. So fuck this shit. Okay, so authorize, yeah. Just fuck it. Gcloud compute config set sorry. Okay, so config set yeah, but give me the fucking options. Jesus fucking Christ. Oh my god. GCP G Cloud config options, config region and zone. Fucking Jesus Christ. So it's GCP Cloud Shell, G Cloud, set region and zone minus google.com. I think that Google is not capable of giving instructions on their own system. Oh, fucking Jesus Christ. This is what I wanted. So now we have this command and we want US West 4. We have the region set. Now we go for the zone. The zone has this West 4B. Naming normal usually blah blah blah. So task create jump shot instance. Now name the instance. Okay, so G Cloud compute instances create. Okay. Oh my god. Create instance in the US West 4B zone. So GCP Cloud Shell, G Cloud compute instances create tags. Instances create. So accelerate output. Now we want to set the zone. So zone US, okay, minus zone. And is US West 4B. Use an E2 micro machine type. Machine type. So machine type and the machine type is E2 dash micro and use the default image type Debian Linux. So we just go with it. What the fuck? Now we go. Already exists. What the fuck? Oh my god, so it memorized everything. Oh, great. So I can already check my progress here. So set up an HTTP load balancer. Create an HTTP load, manage an instance. Use the following code to configure the web servers. The team will replace this with their own configuration later. So create an instance template. Don't use the default machine type. Make sure you use E2 medium as the machine type and create global template. And they will need this. Use the following code to configure web servers. The team will replace this when Jinx. Pop, pop, pop. Oh my god, in reality, I need to redo everything. Instance group. Delete. Because the instance template which I need to create is missing the metadata. E2 medium. Advanced options in networking, network tags, HTTP allowed. Network security management, disk reservation, metadata. Add an item. No, how is done? Fuck. So we have the network tag. This is a global instance template. Has its metadata. Create. Now to create the instance group. Sorry, the instance template we need is this one, 64.6. So create an instance group. Instance group 1, 64.6. Yeah, so US is for West for B. Okay, so equivalent code. Create. So now we're creating again the instance group based on our template. Create a firewall rule, we already did it. We can check this here in firewall rules. We have it. Create a backend service and add your instance group as the backend to the backend service group with named port. So we go to load balancing. We go to backends. Create backend service global. The name will be backend service global. So let's see, get equivalent code. My Jesus fucking Christ. HTTP, fuck you. Done. Make sure that all fields go to issues. What the fuck are the issues? Health check. Basic check. So create a backend as a backend to add your instance and add your instance group as the backend to the backend service group. So we have this, right? Because we assigned instance group protocol HTTP new backend. Okay, instance group, this one, port numbers 80. Okay, so now we have this backend service and add your instance group as the backend, blah blah. Create a URL map and target the HTTP proxy to route incoming requests to the default backend service. Create a URL map. From where do we create a URL map? Okay, so sorry, then we have entire issue to route incoming requests to the backend service. This will be something we do here. VPC networks. And that will be something here. It's a kind of a forwarding rule. Or maybe in load balancing. No. So again, we need to create a URL map and target the HTTP proxy to route the incoming request to the default backend service. Ah, shit, I don't remember. Create a target HTTP to create a forwarding rule. So gcloud compute URL maps. So list, create and delete URL maps for external application, load balancer, internal application, and traffic director. For more information about URL maps, so let's see something which is not documented by Google. Useless Google. Fucking hell, how bad they are in talking about their services. Yeah, create multiple web server instances, create an instance template, pools, create managed instance. Okay, so external IP, we have this rule, forwarding rules, create engine sleep or started pool, compute forwarding rules. So create health check, create HTTP basic check, compute instance group managed, set, blah blah blah, update, create a backend service, allow instance group in the backend service. So one default service engines backend. Okay, so BE service. Now I see. So it's just matter of really defining URL maps, create web map. Sorry, compute URL maps, create web map. So gcloud compute URL maps, create web map, default backend BE service, right? Default service. Nice, okay. Create a target HTTP request to route request to your URL map. So now an HTTP proxy will be something we find in the load balancing. Okay. Create a target HTTP proxy to route. Okay, compute target HTTP proxy, create HTTP. Okay. Compute target HTTP proxy, create HTTP proxy URL map, web map. What? Private. So I wanted to first of all see if we have web map. Let's see. Service cloud. Oh. HTTP proxy. gcloud compute GCP proxy. Target HTTP proxy create. So create a forwarding rule. Ah, my Jesus Christ. So I cannot resume that page, right? We need to go to VPC firewall. Forwarding. So it's in load balancing. How do I create it? Fucking hell. It's always so difficult to just GCP create forwarding rule gcloud compute minus googlefucking.com. Oh my god, the fucking keyboard. Google.com excluded. How do you retry rule? So some examples maybe. No, nothing, no examples. What the hell? People so selfish. So it will be something like this. It will be, my god, target HTTP proxies create URL map, web map. No, but I already created it. So Sorry, what the hell? Forwarding rules. Okay, so I will create this forwarding rule. It will be called forwarding rule. It will target the HTTP proxy which I just created, HTTP LB proxy global ports 80 address. So maybe I need to create a static address. I will send this command just to receive an error. Okay, therefore g cloud compute addresses create GCP g cloud compute addresses create static IP name subnet. But can you give me a fucking example? Jesus fucking Christ. So create static IP name, region, subnet. I think I will just use an AI tool. Oh, I cannot use it. GCP G cloud compute addresses create example. So let's start with copying this. We already have it. So the name will be st address 1. Description endpoint network will be default. Network type prefix purpose subnet addresses. Whoa. My god, I have a problem with my leg. Addresses IP version 4. Ouch. This is hurting. Oh no. Global. Oh my god. Jesus fucking Christ. Ah, ouch. My God. Oh. I will copy it from the other labs. If I find it somewhere. I'm creating an application load balancer, so I will set it like this. Now I can create the forwarding rule. And this is the last part. Okay, so now let's see if we can check our progress. With 2 Nginx web servers. Okay. Let's see if we can change to okay, let's see. But you're not giving me any indication of what is missing. Create a website behind HTTP load balancer. You know what? Fuck you. So create an instance template, I did it. E2 medium, create a managed instance. Yeah, create a firewall rule. We have it. Yeah, firewall rule with that name. HTTP allowed. The instance group have name instance group monitoring. So these are our machines. They are of the same type of this template, E2 medium. Startup script. Let's see if we can check these machines running. They do not have HTTP. Fuck. Do they have the tag about the HTTP networking? HTTP allowed. Therefore, if I go here in VPC firewall, so this rule is for HTTP allowed and is enabling this. Okay. So applicable to instances, internal, external IP ranges. Let's see if I go and check this machine here. What? It's not serving me. My God. Okay, why it's not serving me? Like Carl HTTP this machine. Why is this happening? Yeah, I got into trouble. All IPs. Allow. Let's edit it. So something is not allowing me to connect to the machines. We have instances. Let's see one thing. Is this machine really running engines? We can go nps aux fucking pipe symbol Linux we grab engines. It's not running. Instance group. Let's see if we run an instance group restart replace VMs, restart maximum level instances. It's updating. Let's see. Let's try again. If we go to instance groups, we're having many issues with these machines. I'm not sure what happened. However, they're not reachable for some reason. I will try again to SSH into one of the machines and to see if PS aux pipe grep nginx is getting nothing. So yeah, I will leave it for now. So I failed this lab here. For now, I could not complete it. I will need to try it again later. So I can complete this course. So thank you for being with me in this video. I will close it for now.